My talk is going to be on pen testing Cordava applications, and I'm Nishaanth. I've been working in security for the last 7 years. I've been mostly consulting, and right now I'm working with MDSec as a AppSec consultant, and the previous job I was doing, I was into mobile application security, and presented in a few other conferences. All of them were online, and this would be my first offline talk. And so the agenda for the talk is we are going to touch upon basics of Cordava, what's a Cordava application, and some of the vulnerabilities which were present in Cordava earlier and patched right now, and also some of the security features provided by Cordava, and also some of the security measures which you can take to prevent common vulnerabilities in a Cordava application. So, why mobile pen testing? The use of mobile applications have exponentially increased in the last couple of years, and also if you see the research which comes out for mobile application security, it's usually Android or iOS, and most of the research focus on Android and iOS and not on hybrid applications like Cordava. Cordava being just one of them, there are multiple other platforms like Flutter, and there's Xamarin, React.js, and so on. And also, if you see, a lot of companies have started moving towards hybrid applications in terms of mobile because of the ease of developing the application, and you also develop the application once, you can deploy it for both iOS and Android as well. So that's it. And so before we start with Cordava, I just wanted to highlight some of the developer assumptions in terms of mobile applications. So when most of the mobile application developers, they usually have a lot of inbuilt protections which are client side. For example, mostly think that if my application is written for if I have protections towards jailbreak, the application is not going to run on a jailbroken phone, or the user is not going to use a rooted or a jailbroken phone to install and use the application. And also, apart from jailbreak, there are various other protections like SSL pinning, where you pin the certificate towards inside the application, so that someone who's testing the application, they won't be able to see the traffic in bug, and also the integrity checks which are there on the mobile side. So no adversary would be able to reverse engineer my app and change the code. So these are all some of the assumptions, but all these client-side protections, do they really protect the application? I would say yes and no. For a very mature organization, it makes sense for them to build or incorporate all these additional security measures. But for any application which does not have any protection, or they do not have any API level security and so on, it doesn't make sense just to obscure the app, because with enough time and resources, an attacker would be able to reverse engineer the app and bypass all jailbreak or integrity and so on. And so with Cordava, basically Cordava is a hybrid development platform written on HTML and JavaScript, using HTML and JavaScript. And one of the main features of applications being written on Cordava is the whole environment of Cordava is sandboxed. So it should not be able to access the file system or camera or geolocation and so on. But most of the not most, I think all of the applications which we use in day to day needs access to geolocation and whatnot, files, camera and so on. So how does Cordava still manage to get access to the native operating system APIs? Is that even though the web view is sandboxed, Cordava basically exports this component called JavaScript bridge or an interface, and that interface can talk to both Cordava and it can talk to the native operating system. And by default, there are a couple of APIs which are exported, and using the bridge, a Cordava application can, get access to photos or get geolocation and so on. And again, the permission should be declared in the manifesto info.plist for for the functionality to work properly. And the config.xml, which we'll be looking on, is one of the key files in Cordova, which in terms of audit, it's one of the key files. And yeah, this is the first one is the implementation of the bridge. So you're just enabling JavaScript using set JavaScript enabled, and you create an interface, and I just called it bridge, and you can load a URL. This can be using a file protocol, or this can be a direct HTML JS external URL. And with iOS, you can initialize WebView and call evaluate JavaScript, and using this, the iOS's JavaScript engine will understand that, okay, this is a JavaScript object or a JavaScript file, and will execute it. And in terms of the plugins which we talked about, or plugins and functionalities, so basically you create a listener for device ready. Device ready is the APIs on device ready. On device ready, make sure that the whole Cordova environment is up and running and all the APIs are ready to be accessible. And so you just wait for the listen for the event, and once that starts, and the navigator, like if you see on line number 4, there is console.log navigator.contacts. Navigator is nothing but a global object provided by Cordova, and using navigator you can basically access all the APIs provided by the operating system, like contacts and so on. And this is how you for example, access the contacts using Cordova. That's in Android, and this is in the second one is in iOS. So this is pretty much similar. You just initialize the navigator object and call the corresponding API. So here we're just calling the geolocation. And these are some of the vulnerabilities which were already discussed, discovered in Cordova earlier, and all of these are patched. The two interesting vulnerabilities among these are the third one, which was the information disclosure. Basically, the Cordova's official camera plugin, which was being used, they were storing the data, they were storing all the photos which were taken by the application in the external storage, so that any application of Android, so any application which gets installed in the phone, gets access to SD card so they can steal photos. That's one. And the second one is the universal XSS, which was found in the WebView. And this basically allowed cross origins to, execute JavaScript on the top domain and basically escape the sandbox. And this is the configuration file. It's basically present in config.xml, in the XML folder. And this is under application folder of iOS. So config.xml, you can configure all the APIs, plugins, you can configure some security features, and so on. So the first critical feature of config.xml is basically access origin. Access origin is pretty similar to, content security policy. So if we say set the access origin to start, that means that the mobile application can basically talk to or send requests to any app server, any domain basically. But if you set it to say just steelcon.com, the mobile application can just talk to steelcon.com, and any other domain it tries to talk to, the Cordova will just reject the request. This is very helpful in preventing. It is an additional feature which you can use to prevent excesses, so that people cannot load scripts from different website and send data to different third-party websites. And the next one is allow intents. So intents are nothing but deep links, or it's like SMS / phone / something like that. You can also configure what intents can be used, what cannot be used, and so on. And the next one is the content security policy, which is basically the CSP of web applications. The last one is ATS, or app transport security, which is iOS specific security feature, which was brought, I think, in iOS 12.10, and all applications which are pushed to the App Store of Apple should comply with ATS. ATS is nothing but transport layer security protection. It just enhances the transport layer, making sure that the site is secure, it's not using HTTP, and so on. And some other things which we need to consider while using web views or while writing applications for web views is that the in-app browser, there is this API called in-app browser, which should always be used for opening links which you don't trust, or for example, third-party links or advertisement links. If you want to load that in your Cordova application, it's always better to use in-app browser because it's isolated from the Cordova environment. So it cannot access the contacts and so on, location and so on. The next thing is that one another security flaw when you see in Cordova applications very commonly is that the domain there is this random domain, it's not even the server's main domain. It's declared in the config.xml, and even though the application developers may think that okay, it's loaded in an iframe, the iframe still gets access to the Cordova's APIs and environment so that they can exfiltrate data. So this is again one thing which you should be looking for in Cordova applications when it comes to WebView. And so when we talk about XSS, it's usually we see XSS in web applications. But in mobile applications, XSS are very hard to find because the mobile native iOS and Android engines do not parse HTML JavaScript, just like how the browsers do. But since Cordova is like in HTML and JavaScript, any XSS which is there in the application is going to have a very severe impact due to the fact not only that you can steal the cookies from a specific user or from the specific app. Due to the Cordova's API being already initialized, you can load the Cordova's APIs and get contacts, or you can exfiltrate the photos, you can exfiltrate the location of the current device and so on. And the second one is CVE, which was found in WebView itself, not on the application, but it was found on the WebView itself. When you invoke an intent to start a Cordova application, the whitelisting was not done securely so that it could populate any URL to exploit the WebView or to do it further. So how do we access the native APIs? Is that say we have an XSS, all an attacker has to do is host this specific JavaScript, very similar to this. As we saw earlier, you wait for the on-device ready event, and once that is done, you start talk to navigator object, navigator.connects or location and so on, and you can do an AJAX or a XML HTTP request to send back the data to your server. And this is pretty similar this is for iOS. The second example is for iOS. It's very similar. You initialize the navigator object, you call the APIs, and you can send it back to the server if CSP and access control is not valid. And one another interesting feature or functionality which I discovered by testing Cordova was the way in which you can use the inbuilt browser, the main browser, to debug the applications. But why I was looking forward to debug the application was like if you see banking applications, most of them have a lot of protections, and one of the additional client-side protection is that the whole network request and response which is sent to the server is being encrypted. Apart from TLS or HTTPS, the request body and the response body are encrypted with a static or a dynamic key. So if it is a static, say, consider this example, it is written in Java, and say it is a static key, you can reverse engineer the Java application, and you can basically get the key, and you can use online tools to get back the network body in plain text, which is encrypted. So it looks something like this, like it's basically a normal request, but the whole body is encrypted, like we do not know what's being sent and what's being received. So if this is an application written in native iOS or Android, it's pretty straightforward nowadays due to a lot of tools being available and Frida being available. and there are already a lot of Frida scripts which hook into the crypto libraries of both Android and iOS and print out the key or ID, the whole data, and so on. So if this was the case of a native application, you can basically use Frida, call the specific API secret key specification, and hook into the specific arguments to print out the data, print out the key and ID and so on. But since our application is written in Cordova, and while I was testing this application, I saw that it was written in Cordova, and it was using additional layer of encryption for the request body and response body. And while digging in further, I saw that the JavaScript files had code for encryption and decryption routines, but it was very heavily obfuscated, and for you to reverse engineer that and read it properly, it's going to take ages, just to get where's the logic and to get the key and so on. And so while I was looking into WebView, I figured out that there was so basically, since Android's WebView is Chromium browser, it uses Chrome, and iOS's WebView is basically Safari, which uses WebKit. So since Chrome has a developer options and Chrome has a way of remotely debugging your applications, it should be possible to make the application running in your phone to talk to the browser running on your system and use the developer options or console debugger and so on to get the key. So, while looking into the web view, I figured out there was this set web contents debugging enabled API, and looking further into this, figured out that if we see in 246, it starts that DevTool server. So DevTool server is basically Chrome's developer options. You can start the developer options if and only if this set web contents debugging is enabled. So, but this is not enabled in production by default, but on debug builds it's always enabled. So if you're testing a debug application, you can just connect your phone, go to Chrome inspect, you'll be able to see the web view. But since this was not the case, you can just write a Frida script to hook into the web view, and we know that this is the API or this is the module which we need to hook set web contents debugging enable. You override the function to always set it to true, so the operating system thinks that okay, this is a debug application, and from now on, so on the left is a production application where we cannot see no WebView endpoints, and after running the script, we can see on the end, that set web contents debugging enable set to true and so on. Every time WebView is getting called, this will override it to true. And now we can see WebView for we can see multiple WebView instances. The main one is the Cordova application, and the next one is the Google Ads which is loaded and so on. From here on, you can just click on inspect and set breakpoints in the debugger to. In our case, you can get the decryption or encryption keys. iOS is pretty similar. All you have to do is resign the application with the developer certificate, enable the options in both Safari and your phone, so that they both can talk to each other. And you resign the application with the developer certificate, install it. It should be debuggable. All the traffic, you should be able to see the mobile application data in the Safari's console. And in iOS, there are two main APIs, UI WebView and WK WebView, and UI WebView is deprecated right now because by default it has a lot of insecure defaults. The file protocol handler is enabled by default, the JavaScript is enabled by default, and UI WebView does not support out-of-the-process rendering. So basically, the WebView and the app, if you can compromise the WebView, the Cordova application also gets affected. So this was one such vulnerability where the attacker was able to exploit the UI WebView's API, and since file protocol is always enabled, he was able to send the APC password back to the server because of bad CSPs. while WK WebView is the new one, and Apple is enforcing everyone to use this version of WebView. It has options to disable JavaScript, disable file protocol handlers, and so on, which the UI WebView doesn't have. So if you're using WK WebView and if you're not using JavaScript or if you're not using the file protocol handler, it's always better to turn it off to default. And I was really surprised to see malwares which were written in Cordova. I just found out two though. Like one of them was the Grift Horse malware, and surprisingly, it uses the same. It uses the encryption technique to pack and unpack and and also to encrypt the request body and response body and so on. And for future research, these were the things which were in my mind. But I'm sure there are more adding to these. First, the WebView libraries and the JavaScript interface for parsing issues, how it parses different or malicious components, and find more vulnerabilities in the official Cordova plugins, try to create a malicious Cordova plugin and so on. And also the whitelist model, which we discussed, the access origin. It was earlier possible to bypass it if the access origin was set to say steelcon.com. Any website that has a domain name of steelcon or steelcon.com .evil.com bypasses the whitelist altogether. But this is patched now. So I don't know. Maybe there are more issues with the whole whitelisting model, and you can fuzz and find out more issues with whitelisting. So these are the references, and that was in talk. If anyone has any questions, you should now.
So Apple released that weird paranoid mode, which, as I understand it, starts to lock down some of the JavaScript. Do you know how that affects Cordova apps?
So basically, with WK WebView, you have the option to disable JavaScript, but with UI WebView, you don't have the option to disable altogether. So if you choose to, say for Cordova applications, you choose to disable JavaScript altogether, you won't be able to use JavaScript in your application. Basically, it should be a static HTML page and no JavaScript at all. And when we see a lot of websites or a lot of mobile applications, they do not really need JavaScript because it's just displaying data. So if you can generate the HTML and disable JavaScript, that should be additional improvement.
So does Cordova, does it use JIT tool?
Now, so basically Cordova for Android uses V8 engine, which Chrome supports. And if I'm not wrong, for iOS it uses the WebKit's rendering engine.
Okay.
Yeah. So that's it.